So based on request, so I have decided to take three diagrams for the purpose of our participating audience. So let's go. So I'll be starting from reflection of light across of this system. Gradually we'll go to ray diagrams. Reflection of light, as you all know, is the bouncing back of light rays after hitting a hard surface or a reflected surface. When waves bounce back, not only light waves, other waves also do that, and we have applications for that. But let's keep it about light. So reflection of light is when light bounces back as it meets a reflected surface, maybe a mirror, a shiny metal or whatever that can reflect. The art is that light waves cannot pass through, it cannot absorb it, it can only reflect it in another direction. So it can be shown diagrammatically as this. You have the incident ray being incidented on this reflecting surface, it bounces off in another direction. Then we have the normal. This normal is the line that is perpendicular to the reflected surface or to the point of incidence. I is the angle between this incident ray and the normal. That is, the angle which the incident ray makes with the normal is called the angle of incidence. I. The angle which the reflected ray now, on the other hand, makes with the normal is called the angle of reflection, and that is represented by R. So we have two laws of reflection, which are number one, the incident ray. The incident ray, this ray, the normal to the reflected surface is the second. And the reflected ray all lie on the same plane. You can see that they are on this reflected surface, right? So when you have the incident ray, you have the normal ray in between, then you have the reflected ray. They all lie on the same plane, on one straight plane. Number two is the angle of incidence is equal to the angle of reflection. What this means is that whatever I is what R is going to be. If I is 30, R is definitely also going to be what? 30 degrees. Now, one trick which Fakwaek or other example board is doing is that you can be given the angle here instead. Let's take an example here. You have your reflecting surface, then the incident ray and the reflected ray, and this is the normal. You are only given this angle, let's say 40 degrees, but you have to find R and I. What do we do? If you look at this diagram very well, since we said that this line, this dotted line here, is a normal, this reflected surface, that will mean that from here to here is the right angle. It will mean that this normal makes an angle of 90 degrees with the normal. And what does that imply? That will mean that if this is 40, here is 50, right? 90 degrees minus 40 degrees. That means that I plus 40 degrees will equal to this right angle. Is that what it is? And according to rule 2, to law 2 of reflection, whatever angle of incidence is what the angle of reflection is. I is always equal to R. So if I is 50 here, R also is 50. Is that what it is? Yeah. So let's move on to curved surfaces now. Let's come to curved mirrors or spherical mirrors. Curved mirrors. Of course, you know what a mirror is, right? General mirror. We did that in the last video. It has a reflecting surface and a coated surface. So the reflecting surface is the one that reflects the advancing backwards, while the coated part is not reflecting at all. So we have curved mirrors. These ones are not plain, like the plain mirrors. They are spherical or circular in nature, they are curved. So that's why we call them curved mirrors. We have three of them. We have number one, concave mirror. It's also called converging mirror. Converging mirror looks like this. This part is the reflecting surface, the inward part, reflecting surface. While this outer part, the part that bulges outward, is the non-reflecting surface, let's say coated surface, is being coated. That is, that part cannot reflect at all, it has been covered with something, reflecting surface. And number two is convex mirror. Okay, let's give a little information about this. For concave mirror, the inner part of a concave mirror is is its reflecting surface. Is its reflecting surface, while the outer part is non-reflecting. The outer part does not reflect at all. So we can have this and we can also have this. So the anyway. So far the outer part is the part that is coated. That's the concave mirror. So that's also be like this. Let me come. So far the outer part, the part that bulges outward is the reflective is the coated surface. While the lower part is the reflecting. Then we have convex mirror next. Convex mirrors. For convex mirrors, they also call it diverging mirror. They also call diverging mirrors. Diverging mirror. For these, we have something that looks like this. Same diagram with subtle difference. The inward part is quoted instead now in this case. It will also be represented as this. If you notice, the part that face inward, that goes inward, the inward part is the one that is quoted, unlike this. While the part that bulges outward is the non-quoted part, which is the reflected surface, which is also unlike this. So this is the reflecting part. You can see the contrast. This is the reflecting surface, and this is the non-reflecting surface, which is the coated part. Non-reflecting surface. For this, the outer part, is the reflecting surface, while the inner part is non-reflecting. While the inner part is non-reflecting. So that is it. We don't like these parabolic mirrors. Parabolic mirrors. This one's give parallel beams of light. Parabolic mirrors. So it is a special type of concave mirror. It's parabolic in nature. It's in the form of a parabola. A special type of concave mirror. Looks like this in form of a parabola. So the outer part is coated and the inward part is the reflecting surface. So any rays hitting it are reflected parallel to one another. Parallel to one another. That being said, now let's come to the parts of the mirror. We want to focus our attention on concave and convex mirrors now. So concave and convex mirrors. Let's talk about them in detail now. Concave and convex mirrors. So our focus will be on concave mirrors along the line. Let's start with concave mirror first of all. So we have this point as point B, somewhere here as point F, and somewhere here as point C. Now, this is like a cross section. I'm going to draw something now. I'm going to draw a sphere. Don't mind the diagram, it's not so accurate. So let's take this as our sphere. Don't mind the diagram. Let's take this as a sphere. So we have somewhere here which is the center, right? I'm going to call this C. Yeah. I'm going to call this distance here. I'm going to call it um, okay, I'll come back to that. So this is C, and the outer part of this is shaded. The outer part of this is shaded. We are going to see what this means very soon. The outer part of this is shaded. Yeah. So let's explain what each thing means. P is the pole. F C is called the center of curvature. The center of curvature. What else do we have? There is R, which is called radius of curvature. Radius of curvature. That's the distance from here to here. It's called the radius of curvature. Yeah, that's it. So this is R. I'll come back to that. Radius of curvature. What else? The 90C itself is called the principal axis. Principal axis. If I remember something else, we go, we look at